still part of module number 6. This is now still part of module number 6. Module number 6, how about arc length? We can solve, we have already identified how to solve for the area bounded by an arc or a curve or a parabolic curve. How about the length of that parabolic curve? This particular method or integral part of integral calculus is important in terms of identifying the point or the arc of a specific cable bridge. So kung kayo ay magko-construct ng isang cable bridge, meron yung arc cable support. Using this particular method, you can solve the length of the cable at which it will deflect. Pwede nyo ma-solve yung length ng cable bridge using this particular method. Okay. Now, diretso na tayo sa formula para madali nating matapos. For arc length, solving for the arc length of a specific parabola or a specific curve, kung dati, that is differential of a side, dati differential area, ngayon differential of a side is equal now to the integral of lower and upper limit. Ano ba naman yung internet? Ang bagal. Upper and lower limit times the square root of 1 thus differential of y over the differential of x squared. Depende doon sa opening ng ating upward, downward, left, right, or ng ating parabola. So this will serve as our general formula in identifying the length of an arc. Okay, meron pa kasing surface area, pero hindi nyo naman na masyadong gagamitin. Dito na lang tayo muna sa arc length. Then for the arc, that is now, let us try to solve this problem. Find the arc length of the parabola y squared equal to 4x from the vertex to a point where x equal to 4. Now, again, find the arc length of the given parabola from the vertex to the point where x is simply equal to 4. Given na yung ating parabola, identify lang natin yung ating vertex. Kasi sabi niya, arc length from the vertex to x equal to 4. Completing the square, that is y minus 0 squared equal to 4x minus 0. So simply our vertex is located at the origin. 0, 0. Then 4a is simply equal to 4. A is equal to 1. 2a is equal to 2. Distance from the directrix to the focus is equal to 1. The latus rectum is 4. The focal length is simply equal to 2. Plot lang natin yan sa ating Cartesian plane. Vertex mo is 0. Your arc, sabi niya, at x equal to 4. So, ito ngayon yung ating boundary line. So, ang boundary line natin is at x equal to 4. X equal to 4. boundary line. Okay? Kasi yung ating distance from the directrix tsaka sa focus is equal to 1. But it was defined in the problem that the arc length should be considered up to x equal to 4. So, eto ngayon yung ating parabola. Ay, oo nga pala, positive ha, y squared, then positive 4a. So, at y-axis, opening to the right, positive. Positive 4a, so opening to the right. Alala nyo pa yung shortcut na binigay ko last meeting? How
Yes,
to
sir.
identify the opening of your parabolic curve. Positive, y-axis, positive to the right, negative to the left. X-axis, positive upward, negative downward. So, yun lang yun. But kasi dito, dinefine na ng problem yung boundary natin is at x equal to 4. And positive 4a, so opening to the right. Okay? Then, if x is equal to 4, ano ngayon yung maximum opening ng ating parabolic curve? So, if x is equal to 4, what will be the, what will be our maximum latus rectum? Okay? Such as y, or the parabolic curve, is equal to a y, or a y squared equal to 4x. Substitute lang natin si 4 sa ating x, then square both sides. So, maximum y ordinate point is 16. Square root of 16, that is positive 4. So, this one is y equal to 4, and also a negative 4, and also this one, y is equal to positive 4. Meron na tayong basis later on for the maximum minimum value. Ngayon, with arc length, na natin kailangan mag-consider ng strip. Okay? We no longer need to identify vertical and horizontal strip. Just complete the formula. Even. Ano yung mga variable na yan? Hanapin lang natin si dy dx and your upper and lower limit. For your upper and lower limit, basically, complete curve starting from the origin up to the boundary line. So, makukonsider na natin lahat nung yung buong arc length. So, from the origin to the boundary line, so yan na yung inyong limits kasi x to x. So, for your arc length, s, x to x, square root of 1 plus dy over dx squared dx. Okay? But in this problem, that is, the arc is on y-axis. So, with respect to y, so baliktarin lang natin yung variable na isa, that is 1 plus dx over dy squared. So, dy. Okay? Then, identify dx dy, which is the differential of d over dy, y squared equal to 4x. Differentiate lang natin yan. That is 2y equal to 4 dx over dy. Or dx over dy is simply equal to 2y over 4. Meron na tayong dx over y. Then, substitute lang natin doon sa ating formula for arc length. For arc length, ano yung ating lower and upper limit? Complete curve from origin to the boundary line. That is 0 to 4. Square root of 1 plus dx over dy was 2y over 4. Then square, then dy. Simplify lang natin yan. That is equal to, mamaya ko na ibalik yung ano, 1 plus 4y squared over 16 dy, or simply 16 plus 4y squared over 16 dy. Simplify mo pa. Simplify pa natin yan. That is also equal now to 4 over 16, 4 plus y squared dy. Parehas lang naman, di ba? That is 16 plus 4y squared all over 16. So, more or less ganyan. Then, square root of 4 square root of 4 over 16, that is what? 1/2. Then, ang natira na lang is 4 plus y squared dy. 0. So, meron na tayong constant. Okay? May constant na. Then, arc length is simply equal to 4, 0, 1/2 square root of 4 plus y squared dy. Y squared dy. Now, apply your integral calculus, your integral formulas to solve and simplify and evaluate this given definite integral. Then apply your upper and lower limit, and it will eventually give you the arc length 5.92 units. Units ha, length ang pinag-uusapan, hindi area. Apply nyo na lang yung evaluation method ninyo for integral formulas. Using your integral formulas, then you should come up with an arc length equal to 5.92 units. Pwede nyo ring i-check yan sa inyong calculator. Merong definite integral sign doon sa calculator for you to check that answer. Okay? Alam nyo kung nasaan sa calculator yon?
Yes, sir.
Check nyo na lang doon. So, you need to apply your solution in evaluating this definite integral. Then, you'll have the value for your arc length, 5.92 units. So, that is simply plane areas and arc lengths. In addition to module number 6, plane areas and arc lengths or area bounded by a curve, how about if we're going to have polar curves?